Alright, so, last time we made good progress. We finished off the dashed area. I think, I can't remember what happened. I was like halfway through an area. Did I finish something and then finish dashed? Yeah, I don't remember how it was all split up. Whatever, everything's going well. I think I've only got the ghost section and the colors section. And apparently 7-7 I didn't understand. Yes, this is this one. Yeah, okay. I know which one this is. It's where the direction of the arrow, the way I ended up solving it was by going, oh, I just have to turn the direction of the arrow after the arrow. And that still works. And just not go ahead of it. If I go ahead of it, it ruins it. If I go behind it, what happens? It also ruins it. Second one's ruined. Second one's ruined. Ooh, that's ruined. So that's fine. That's not fine. Yeah, I want to figure out what the actual rule is for this, because I think it's probably the only one I haven't at least... Yeah, it's one of the only ones where my rule that I was using was so vague and I definitely wasn't anywhere near understanding it properly. All the way around also works. Is it exactly symmetric? I think it is, yeah. So as soon as I go back, we have a problem. There are 3 rules going on. So some of these were about like not going in front of or behind the thing. Could be the middle one. Everywhere is fine except in front and then behind. Let's try this on here as well. I'm sure it's going to be the same, right? This is just showing me that it's directional. Yeah, yep. In front and behind fails too. The first one's probably just go through all of the triangles, I think. Yeah, I think so. So going in front of these fails it. Going in front of here, behind here, fails it. Anywhere else doesn't fail it. On the thing doesn't fail it. Because of course it can't, because that's required for the first rule. Here, here, fails it. Here, doesn't fail it. Okay. But it's not just don't go in those spaces, because then I could just do that. There's something else. There's this third rule. So that's interesting that doesn't work, because that's the equivalent of that, really. That makes it successful. And that. What? How? Why? So nothing on that row is changing between there and there. Only that's changing. So maybe it's like everything on this side of the arrow, not just on the same row, but everything over here and everything over here somehow is relevant. Well, if I keep going, it works. It stops working, because that one is leave it empty. It's the third thing that I'm trying to figure out. Does it matter how much of this I fill in? Apparently so. Does filling in these ever make it succeed? No. Because I'm going in front of them and behind them. Yeah, okay, of course. So there's not many things I can even experiment with here. It's just that, and that. So this is trying to tell me something. The fact that that's so constrained. So this is failing right now. That succeeds. That won't succeed. That won't succeed. Okay. Succeeds. Doesn't succeed. I know what the first two rules are, right? Go through every triangle, don't go in front or behind the triangle. This is something else. To do with what was happening over here. What about if I add stuff at the back? Wait, what was it? This. Or this. That works. Wait, that didn't work. Okay, so adding stuff at the back can also affect it. Number of empty spaces in like on this side and on this side. 1, 2. 1, 2. 2, 3. Okay. Like this has to be smaller than that. So if I do this. Okay. So the problem if I don't go to the edge is that they're kind of joined together, I guess. That's a bit of a weirdly vague rule. But maybe, yeah, if you just like, oh, maybe you start with the one that's in front of it and you count how many are connected to it. Oh my gosh, it could be that. Start with the one in front of it, count how many are connected to it, and that has to be less than how many connected to the one behind. Is this the rule? It works here if I think about it like that. If I think about it the other way though, where I was like, oh, 4 in front, 3 behind, then that doesn't work. So what if I do, is there anything interesting I can try here? Like this, still works. But if I remove 1 from back here, it doesn't. I think I've got it. Okay. Okay. Well, in which case, I've done them all. Let's just double check them, I guess. 1 in front, 2 behind, 1 in front, 2... Yeah, okay. What a weird rule. So in theory here I could do probably something like... no. More behind is what I want, right? In which case can I really do that? Yeah. Yeah, it's working. Okay, it's working for all of them. So more behind, but less in front. So what? That's why. I was going to say that has to be separated. No. Right, we've got 4 there, 1 there. This is going to have to be, if these were connected, which they are in the actual thing, then that's 3. Therefore, this has to be a 4 or more. So let's try more. 6. I'm pretty sure I've got it. But then I can't get there. So that has to be the start. This might be the only solution, actually. Is there a solution I can get by going this way? I guess it's the same solution. No, it's not. Well, it would be if I did this. Yeah, I don't know if I can get a different set of numbers, though. Okay, I think I've got it anyway. I think I got it. Yeah, that makes sense there. Yeah. How did I solve these like this? Wait, have I left one bad? I think I have somewhere. Here we go. First one. Neat. Okay, cool. That was nice to go back to. Now this one is another one that I solved but did not solve. I need to write the numbers down again, I think. I think there's a pattern I'm missing. Because this was, I remember what this is just purely fill in a certain number of the spaces. Therefore, the number has to be relevant in some way. So the only way I can see how I could get to that is by writing it down. So I'm going to do it. I've got to erase my whiteboard. Okay. So what do we have? This one needs to be entirely filled in, yes? There was never any occasion where there were 2 options. And what? Okay, so 3 wide, 1 tall. entirely filled in, which is 3 squares, or 1 over 1. I'll write it as, I guess. This has to be all 6, isn't it? I think so. So 3 by 2, 6, 1, 1. Let's keep going. 4 by 2, no, by 3. Whoops. 4 by 3. All 12? I mean, I should double check. So it's another 1 by 1 over 1. Pretty sure this was like every one only took a very specific number of things. Okay, and now we've got one that's not all of them. 2 by 2, 2 half. Doesn't matter which 2 I do. Doesn't matter which direction I do them. Any more, any less, it's worse. Okay. 3 by 3, 3. No, sorry. 3 by 3. Yes, 3 by 3, 3. 1/3. I think I've got it. It's really simple. I thought about this. I even thought about this at the time, didn't I? I think I was getting confused. I was looking for common denominators at some point, which I guess this is not what this is. I think what it is, because the number that I'm filling in with each one is always a multiple of the previous 2 things. And I think it's the lowest multiple. 4 goes into 12, 3 goes into 12. There's no number below 12 that both 4 and 3 go into. 2 goes into 2, 2 goes into 2, there's no number below, obviously. 3 and 3, 4 and 2. It's actually a really basic relationship. I mean, it could be even more basic, I guess. 4 and 2, I'm filling in 4. Yep, that worked. Okay, okay. So the problem I had last time is that I was focusing on the fraction for a lot of it, and the way I wrote out the numbers was to put I did the width, the height, then the fraction, and then I think later on I decided to add just the number. And it's hard from the fraction to realize. Yeah, because the fraction's now making it about the total size of the thing, but the total size isn't relevant. Except that the total size is a common multiple of the 2, the width and the height, obviously, because it's the width and the height multiplied together. But it's not always the lowest. Yeah. So because I was so distracted by the fraction, like what proportion is it of the whole, I was being caught up on the fact that the whole isn't actually all that relevant. Like this could be double the height, the answer would be the same. No, it wouldn't, because the height would change it. The answer would be the same. It would be 4 by 4 and the number would be 4. Ah, okay. I can do them now. I mean, I've already done them. So 6, 4. 4 goes into 12. Yeah, there we go. 3 and 6. 12. No, 6, obviously. Yep. 8 and 4. 8. Yep. All of them, apparently. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, because it's 9, and 9's an awkward number. 4. 9. 18. Yeah, because it would be 16. So 36, yeah. 36 is when it becomes a common multiple of 4. And we've got 8 and 6. 8 and 6. So 8, 16, 24 is when it becomes, yep, 8, 16, 24, yep. Okay, and that might help me with this one then. Okay, because again, it's fractions in some way. Let's not think about fractions. Okay, and did I even attempt this one much? Obviously, I did fill in some of them. In fact, many of them. But maybe because I was focusing on the wrong kind of things, I was like, or maybe when I came to this one, I didn't really think too much about it. I was just like, well, I didn't understand the previous. How am I going to understand this one? Okay, so what have we got? We've got 3 by 1. 3. I'm going to put the fraction in as well, just in case this time it is relevant. I mean, it is relevant. It's just it's hard to go from the fraction to realizing that it was the common multiple. Anyway, is that okay? I need to double check. Is that the only thing here? I don't really remember much about this level, so I shouldn't try clicking different, like the same length all over the place. So 3 by 2, 6. This is going the same so far. I should be worried. 4 by 3. So we know common multiples a thing, so it's probably not going to be something significantly worse than that. So if this were common multiple, it would be 12. But it's not, it's 3, right? It's 3. Now that isn't that weird. That's smaller than 4. Okay, what's the fraction? 3 out of 12, a quarter. It's smaller than 1 of the lengths. Let's keep writing them down. I think I need a few more examples so I can start thinking about it. I mean, yeah. So 2 by 2, 4. 2 by 2, 4. I started writing an X for the by. 2 by 2, 4. So the whole thing. 3 by 3. I was just about to say, it'd be good to know what 3 by 3 is. It seems to always be the whole set. 9. If it's square. They're not all square numbers. We had some 3s. This one's 8. 4 by 2, 8. Should I just write down all the examples? But I feel like it's silly because, like, I mean, which one did we even get to? 4 by 2, this one. Okay, let's look at the numbers now. So there's only one case I've had so far where the answer is less than one of the numbers. It's the 4 by 3 situation. So the lowest common multiple of 4 and 3 is 12, which 4 goes into 3 times. Lowest common multiple of 3 and 2 is 6. The answer was 6. It's not lowest common multiple though, that's the one we just did. Oh no, what could it be? Something to the power, something else? Something... I keep doing the thing where I'm like, oh, the width times the height is the number. But, oh, that's, I mean, yeah, that only works for some of them. Where it's like 1 over 1. So they've all been 1 over 1 so far. No, that's not true. Yes, it has. They've all been filled in so far. Except one of them, that one. What's the difference? What's the difference? 4 and 3, why are you special? But 3, 1, 3, 2, 2, 2, 3, 3, 4, 2 are not. This is hard. 4, 3, 3. What's the relationship? Some kind of modulo thing? I'm just trying to think of maths things. One's into 3. Some kind of modulo thing. Doesn't explain the 4 and the 3. Quarter. So is that the only... No. So in every case we've had so far, the width is always greater than the height. Do we have examples coming up where that's not true? No. No, not at all. Oh, no. Is that important? What about in the other one? Did we ever have that? No. There's really no reason to have it always like that, but okay. What is the connection? 3, 6, 3, 4. Maybe if I draw them on a number line, something would pop out to me. Should I do it? Okay. Number line. Do some dashes along it to represent each number. I mean, I can't draw a very long number line. So again, sorry if my audio is bad, because it's because I'm looking away from the mic. So what's that? 0, but that's never come up. Whatever. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. My number line is 13. So for the first one, 3, 1, and 3 is the thing. 3, 2, and 6 is the thing. 4, 3, and 3 is the thing. That's the weird one. Nothing's turning out to be so far. 2, 2, and 4. 3, 3, and 9. But the fact that those are squares can't be coincidence, right? What else is a square sometimes, but not every time? 4, 2, 8. And often it's just the two numbers multiplied. 3 times 1 is 3. 3 times 2 is 6. 3 by 3 is 9. 4 by 2 is 8. 2 by 2 is 4. I mean, yeah, again, in most of the situations, I've filled up the entire grid, except the 4 by 3 case. Why are you special? Maybe I need some more. I need to find another one where I'm not filling it up, right? Which is this one. 6 by 4. It's apparently 6. A quarter. It's clearly never going to do it again, but I'll keep going. Oops. Ah. Yep. 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 Okay. 6 by 4 is 6. A quarter. So we got another quarter. Then we've got the half, 6 by 3. Oh, what's the connection here? 6 by 3 is 9. Which is a half. Okay, so do the two numbers always go into the number I'm doing? No. No. Like, so the first bunch of levels, or puzzles, whatever we call them, they do, except for in the 4 3 3 one. 4 doesn't go into 3, obviously, it's bigger than it. And then we get down to the 6 wide ones, 6 and 4. They don't both go into 6. 6 and 3, they don't both go into 9. However, let's do the common denominator thing. What if it's that? Common denominator of 3 and 1 is 1. What's the connection? Is it how many times it goes into the width or something? Common denominator of 3 and 2 is 1. Common denominator of 4 and 3 is 1 again. Yeah, what am I doing? 2 and 2 is 2. 3 and 3 is 3. I mean, maybe I should write it down. It might be relevant. Okay, I'm going to write them down. Common denominators. 1. Sorry that there's no action in the video. 1. 1. 1. 2. 3. 2. 4 and 6 is interesting. It's 2. 3. Can I see a connection? Something to the power, something else. 1. I've just got loads of numbers to try and find connections between. So could those be powers? The lowest combinator is the power of something else. 3 squared is 9. I'm not seeing it. 3 squared is 9. Over 4, 1, 2. It's not this. What other mathsy things are there? I feel like I just have to make up ideas here. There's no. I don't know how I would deduce this. There's no deduction here. This is, well, oh yeah, I guess it's not deduction anyway. But there's no induction. There is induction, but yeah, I mean it's kind of the purest form of induction. You've got some sequence of numbers. Find the pattern. So that's 6 by 3. What's the next one? 8 by 4 ends up being 5. Well, that's a really weird one, isn't it? 8 by 4 ends up being 5. Which is what fraction of the total? 8 by 4 is 60, 32. 5. Which is 5/32ths. I mean, yeah, I don't think I can simplify that, can I? 2. I don't think I can simplify that. Yeah. Okay. Well, that makes me really think the fraction is not relevant at all. Lowest common denominator of 8 and 4 is 4. 8 and 4 is 5. Where's that come from? What does 5 have to do with anything? Maybe I should just do some math. Like 8 times 4 is whatever it is. 32. What's 5 have to do with 32? Also nothing. Okay. This is 5, right? Yeah, 5. It's filled in, so... Yep. That's super weird. 5 and 8 and 4. What's your connection? Is there going to be some silly, like sometimes you get those paper puzzles that you get in magazines or newspapers or whatever, where it's like a bunch of numbers around a circle or something, and you're going to fill in one of the numbers, and it's always like, oh, you have to take the number that's opposite and the number that's next to the opposite one and do some weird random maths with it, and then, oh, you get the one that you're looking for, and that's the pattern. Is it going to be something like that? What maths can I do to 8 and 4 to get 5? 8 minus 4 plus 1. 8 divided by 4, 2 plus 3. No. This is our second example of the output number being smaller than one of the input numbers. Maybe I'm making a mistake to think of them as, like, maybe there's nothing to do with the width and the height here. Could be completely unrelated. Could just be the total. And so 5 out of 32 is an important number. Could it be something like to do with the number of vertices rather than the number of squares? Or number of lines? There's a whole bunch of things it could be. Maybe I should write down some of those numbers as well, because I can't see how 8, 4, and 5 could be connected in an interesting way. Vertices? 1, 2, 3. Well, let's do all the simpler ones, I guess, first. 1, 2, 3, 4, 8. 8 and 3. What's the connection there going to be? Nothing. But I'll put it down anyway. 8. 12. This is 5 along the top, 4 times 20. No, I'm not seeing a connection here. This is going to get massive quickly. 3 times 9. Oh, I'm doing them in the wrong row. Whoops. 9. No, I'm not seeing a connection. I'm going to rub that out. I think that's very not the right thing. But lines could be relevant, I guess. Or like number of rows plus number of columns. That's also a thing that could happen. 1, 2, 3, 4, 5, 6. 6. I could see that being related to 3, sure. 1, 2, 3, 4, 5, 6, 7. I do not see that being related to 6 in any way. 1, 2, 3, 4 plus 5, 9. Could be related to 3. I'm not confident about this though. Number of rows plus number of columns. Well, that's literally just the width plus the height. 4, 5, 7, 4, 6, 4, 5. No, there's no connection. How do I get from 8, 4 to 5? Can I find another weird one? Which one was that? 1, 2, 3, 4, 5, 6, 7, 8. Well, it's the 8 by 4 one. Why don't I just look for it? 8 by 4. Here. I'm like almost at the end. Okay, what's this one? Give me another weird number, please. Please. Another weird number. It's a pretty weird number. 9. So what is this? This is well, it's not that weird when it is a 9 by 4 thing. 9 by 4, 9 a quarter. Is it something to do with the total? No, because the 8 and the 4, the 8 by 4 one, the answer, the number that I put in was 5. So it was, but the total size was 32. What do 5 and 32 have to do with each other? Nothing. Nothing at all. Two, 4, 8. 2, 4, 8, 16, 32. 2 to the power of 5 is 32. But 2 to the power of 9 is not the same as 6 times 3. 2 to the power of 3 is what? 8. Okay. Yeah, I don't really like these puzzles because there's not much to go on. Can you find the vague pattern in all of the mess? Powers. 3 to the power 1 is 3. 3 to the power 2 is 9. 4 to the power 3 is... Powers kind of get out of control very quickly, don't they? Like 6 to the power 4. 36, yeah, like it's not going to be powers. Roots. The opposites of powers. What's the third root of 9? Eight, 4, and 5. What's the connection there? 8 plus 4 is 12. 12 minus 7 is 5. 6 plus 3 is 9, no. The problem is that the number that's the answer is often nowhere near the numbers that are in. Or like, sometimes it's within them, sometimes it's less than them, sometimes it's above them. Okay, it's never been less than both. That probably tells me something. Like, yeah, something like it's the... No, I don't know. 8, 4, and 5. What's that about? 5 goes into 10, 15, 20. Do any of these have any connection to those numbers? Like, the only time they end up joining up is once we get to 40, right? 8 times 5 is 40. 4 times 10. I mean, that's 8 times 5 is 40. 4 times 10 is 40. 5 goes into 40. What point does 6, 3, and 9 become connected? At 9. Well, no, not at 9. At 18. 6 goes into 18 3 times. 3 goes into 18 6 times. 6 goes into 18 3 times. 3 goes into 18 6 times. I mean, yeah. 9 is half of 18. So 8 and 4 and 5, the only connecting number I've got is 40. That's a bit of a big number. The size of the space was 32. Is there a modulo thing happening? I'm clicking in an answer. Okay, it wasn't that. I'm glad, actually. I don't want to solve it by mistake. Is there a connection to the level number? They wouldn't do that in a non-question mark one, would they? No. It could be any... That's the problem. This, like, it could be literally any mathematical expression. 3, 6, 3, 4, 9, 8, 6, 9, 5. 3. It's all... The answer's always been bigger than at least one of the numbers. What does that tell me? I don't think the fraction's relevant again. I don't even remember what that last number on there is. It wasn't vertices, it wasn't the lines, it was something else. What else is there going on? What kind of property could I count? I mean, it could be interior vertices. 0. Cool. 2. No, there's no connection. Why 5 here? 8 and 4, 5. 8 and 4, 5. Like, I feel like if I can find some connection between these numbers, I'll have it. Are there any other properties of the numbers that I can, like, see? Well, 5 certainly isn't a square number. Neither is 3. Like, not very few of them are square numbers. Primes. Let's see any particular, any particular abundance of primes. Nope. 3 6s, 9s, 8s, 4s, and 5s. 8 4s and 5s. 3 6s and 9s. I don't see a common pattern. Oh gosh, why is this so hard? Let's divide stuff. Let's not do the thing where I just divide the... I mean, I didn't write down the total size of the grid, okay? 3, 6, 12, 4, 9, 8, 24. Yep. 18. 32. And then finally 9 by 4. What's that? 36. Yeah. 3, 6, 12, 4, 9, 8, 24, 18, 32, 36. Would you believe it? Those are all what you get if you multiply the width by the height. Amazing. What's the connection? 532, 84, 32, 5. Where have you come from? 5. 5 watts. This is impossible. How many 6s go into 35? How many 8s go into 40? 5. How many 6s go into 40? 6.66666666666. How complicated does this connection have to be? I have no idea. It could be anything. Do I have to put it into a quadratic equation? I can't even remember the quadratic equation. I remember like bits of it. Square roots of b squared minus 4ac. Now I'm just talking about random maths. There's a bit before that though. Something like 2a or something. Oh, there's the 2a underneath. Yeah, I don't remember. Whatever it is. What are the mathematical? E. That's 2 powers of E. Well, these numbers are the power of E. Like one of them could be used twice somehow. So like 8 squared is what? 64. Ends in 4. Well, that doesn't help. 5. 5 is the important number there. 8 to the power 4. I mean, I could try and work it out. What is 8 to the power 4? Let's just do it on my phone. 8 to the power 4. I can't even think what's 64. I mean, okay, 4096. There's no 5 in that. It's not divisible by 5. 8 to the power of 5. 8 to the, I don't know. 5 to the 2 to the power of 5 was what? 32. 2 to the power of 9 is a big number. 256? No, 512? Yeah, 512. I'm stuck. I'm very stuck. 5, 5, 5. Why 5? Can I see it visually? Can I look at this and go, ah, that's why 5? That's not connected, right? That would be horrible if that was connected. No. If I write them in binary and then and them or them, I've got no idea. I'm just making up random things. Sure. 3 in binary is 1, 0, 1. 1 in binary is 0. No, not 1, 0, 1. 0, 1, 1. 1 in binary is 0, 0, 1. All of them, you get 3. It would be funny if this was what this was. 0, 1, 1. 0, 1, 0, all of them, you get 3, not 6. Definitely not 6. You bit shift the second one. What's 6 in... it's 1, 1, 0. Oh, well, there could be a bit shift. I mean, it's not going to be this. This is way too complicated. But I'll keep going. 4 is 1, 0, 0. Yeah, like you end up with 3. What's my bit shifting backwards or something? And 3 is what? 3 is 0, 1, 1. And I get 3 out of it. Maybe they're not decimal. But then how would that help? Like, I've never had any numbers greater than 10. So what is it? One zero 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 one one, and I result in 3 again. I'm not seeing it. 2 and 2. 0 1 0 0 1 0 4 1 0 0. You carry the. I mean, that's just doing addition. You add them and you carry the 1. A 1 at the top and a 0 at the bottom becomes a 1. A 1 at the top and a 1 at the bottom becomes a 1. So if there's a 1 at the top, there's a 1. No, not in the third case. And not in the second case. Oh, sorry, the fourth case. I don't think it's binary related. 8, 4, and 5. 5. What's 5? I mean, why am I still doing binary stuff? It's 1, 0, 1. Okay. What's I got to do with 8 and 4? Nothing. Nothing at all. Okay, it's not binary related. What other options do I have? 4 and 3, 3. Oh, I really hate these kinds of puzzles. I hate them in their, like, magazine form as well. Like, they sometimes get posted to the puzzles subreddit. It's just the worst, because like, and then this always comes up in the answers that people are like, oh, actually, I found another pattern that also fits. However, I can't find any patterns for this, but still, I guess once you've got like 10 examples or whatever, if not more, it becomes less and less easy to find multiple patterns, but there are always multiple. It's just, yeah, the problem is that the pattern is so loosely fitting to the... It's like you don't have enough information. It's just so loose. Maybe like you'd... No, I was keep thinking about things that where maybe the number in the width in the next one is somehow connected to the height of the previous or something, but then that would be the kind of thing a question mark level would do, not a main level. And the question mark level here was the one where I had to do the time, the date and the time. Four three three 2 2 4 3 3 9 4 3 3. Why? I had no idea. Absolutely no idea. Remainders? If I multiply, if I do 4 squared and then divide that by 3, the remainder is 1. I've already thought about modulo. That's effectively the same thing. It's the remainder after division. Oh gosh, how long can I even think about this for before I give up and just decide this is not my thing? Do I come back to it again? Like, how am I gonna progress? How am I gonna progress? I guess one thing I didn't do when I did the number of vertices, I was always doing the total number of vertices. But what if it's to do with just the width and height expressed by the number of lines? 4 and 2. Answer is 3. Sure, it's the mean. 4 and 3. It's 6. It's not the mean anymore. No, it's not going to be this. Five, 8, 4, and 5. There's no connection. There's no nice connection between those numbers. 4 times 5 is 20. It does not go into 20. It does go into 20 with 4 left over. 3 times 9 is 27. 6 does not go into 27, but it does go into 27 with 3 left over. Okay, this is actually working for 2 of the things. Wait, is this like some... Is this just... No, hold on. What are we doing? What did I do? I did 4 times 5, 3 times 9. 4 times 6... Yeah, what am I on about? Like, what? 4 times 6 is 24, and 26 definitely goes into 24. So, when it's not with 4 left over, I got no idea. Oh yeah, the other number I wrote down was the lowest common denominator, or the greatest common denominator. Lowest common is always 1, I guess. I am not seeing a connection. I'm staring at numbers, hoping that something appears to me like a vision. It's not appearing to me. Where does 5 come from? 8, 4, and 5. That's bothering me so much. So much. I do not understand what the connection between 8, 4, and 5. Or 32 and 5, except for the 2 to the power. That doesn't work for any of the others. You end up with way too big numbers by doing powers. 5. 4 goes into 5 with 1 left over. 8 goes into 5 with 3 left over. To 10 with 6 left over. There could be any like random manipulation of numbers. It could be like, oh, you have to actually add 3 to the width. Maybe I half one of them. No, half 3, half. I mean, possibly. If I half 3, then the lowest common denominator will be 1.5 and 1 is still 3. If I half 3 again, the lowest common denominator, between 1.5 and 2 is still 6. If I half 4, it's going to be 2 and 3, it's going to be 6. That doesn't work. For 3 to be the lowest common denominator, that'd be turning the 4 into a 1. How does that happen? How does that happen? Why is it for the squares, they're squared? As in, obviously the total area is squared, but the number I'm putting in is also squared. Well, why is it for 3, 1, 3, 2, 2, 2, 3, 3, 4, 2, and that's it? Why is it always the whole set? Or maybe also the last one. I think I've rubbed it off the board. Not the last one, this one. I'm almost tempted to do the star just to give me an extra thing, but it's not going to help, is it? I'll do it. I'll like, even if I solve it, I mean, I will solve it because I'll put in every possible thing. But I'll still come back to this to figure it out, or I'll still keep trying. It doesn't matter that the tick is there. Oh, found it. So what is this? This is 8 by 6. And I'm inputting 12. No idea. Absolutely no idea. So the 4 by 3 one was 3, yeah? Yeah. I mean, I know I don't. What? I wonder if I'll need a hint for this one. Okay, I'm gonna have to stop, I guess. It's been like an hour. Not just on this one, I guess, but nothing is standing out to me at all. It could even be, it could be not just pure maths, but also like string manipulation. Oh, if you concatenate the two numbers, you get 31 and 32, and somehow that's related to the answer. 43, 22, 33, or first you multiply them and then you strip off the last digit, and why not, huh? There's just way too many possibilities here. We've done lowest common multiple. What else is there? There's like a similar relationship between numbers. They're not all... No, I don't know. Will any amount of staring get me there? What else can I do? It's not like I can do maths on it to work out. Like, I'm doing maths, but I'm guessing. Just guessing at random equations. How does 4, 3 end up with 3 as its answer? And I just accidentally put marker pen on my desk. And how does 8, 4 end up with 5? 8, 4, 5. What? 4 squared is 16. 8 squared is 64. 5's relevant there? No. 16 times 4 is 64. 6 squared is 36. 3 squared is 9. Also, the width and the heights are sometimes, it's not always like larger, bigger. It is always larger. Larger, bigger? Larger, small. I'm losing my mind. It's always larger, smaller. So 3 squared, 9. 6 squared is 36. 9 to 36. I have no idea. No idea what this could be. Why does 4 by 3 have 3? Why isn't 6 okay for 4 by 3? Why isn't 9 okay? Why isn't 12 okay? Or even 1? 4, 3. 3. Two, 2, 4. 4, 3, 3. 8, 4, 5. Let's just put those two down next to each other. Those are the weirdest ones. 4 and 3. And 3. The total size is 12. I'm going to label these width, height, answer A. 12 is total. What was that? Greatest common denominator. The labels I've labeled my cards with are W, H, A, and T. What? That's exactly how I feel. just looked at the column headers and it just says what. So sorry, there's that one, 8, 4, 5, and 32. What's the connection? 4, 3, 3. Why is it so small? And then 8, 4, 5, it's also pretty small. It's not quite as small as the smallest number, but it's pretty small. Of course, 3 does go into 12, but 5 does not go into 32. 5's the weirdest one. There's not going to be something horrible like number of letters in the number. Well, this is the kind of thing I'm considering now. 4 is 4 letters long. 3 is 5 letters long. 3, okay, cool. 8 is 5 letters long. 4 is 4 letters long. 5 is 4 letters long. Is there really some connection here? I really don't see it. Square one of them, square the other one, subtract them, or something. No. Factorials. I haven't done factorials yet. It's not going to involve factorials, is it? 6 to the 6 factorial? What's that? Well, let's do 3 factorial. 3 times 2 times 1. 6. 1 factorial. 1. Next one was 6. 2 factorial is... wait, yes, 2 times 1. 1. No, 2, sorry. 4 factorial. 3 times 2 is 6. 4 times 6 is 24. 3 factorial is 6. What's the connection? I don't know. Well, if you multiply them by I, and then put them in a matrix and take the determinant, and then find the eigenvalues of that matrix, and then write that down, put it in an envelope, post it to the address of the Pope, then the number of days it takes the post to arrive at the Vatican City is the answer. The problem is, I feel like if I come back to it, I'm not going to have anything else to go on. Obviously, there's the like, oh, I'll have a fresh mind. Maybe I'll see something. But like, what? I have a fresh mind. I'm fine. I sound fine, right? I sound totally fine. There's nothing wrong. Everything's perfectly fine. Where does the 5 come from? 5, 8 and 4, 5. Are the 8 and the 4 irrelevant? Wouldn't that be horrible? But they're not. They're going to be relevant somehow. But maybe again, it's not the things, it's the number of lines or the number of vertices or the number of, I don't know, anything. Absolutely anything. Maybe it's the width and height in pixels. Pretty sure it scales. So it's not going to be that. Let's double check. Does it scale? Yes, it scales. Do I try and include the number of the levels? No way, it's going to be relevant. 1, 2, 3, 4, 5, 6, no. 7, 8. 5, 8 and 4, 5. The difference between them is 4 plus 1. It's actually the date on which this was the score between two particular football teams. So when, I don't know any football team. No, I do, but when the score was 2-2, it was the 4th of July. There's not going to be anything meta like that because it's not a question mark thing. Like a second there, I was thinking, like, what if it really is something very weird and meta like that? There's something about the real world. How many days there are in months. The thing is, the answers go up to 9. And the answer is always a multiple of one of the numbers, at least. It's always a multiple of... No, it's not. 6, 4, and 6. Oh, yeah, 6. 6, 3, and 9. Yeah, it's always a multiple of one of them, except with 8, 4, and 5. 8, 4, and 5? Why? What? One, 2, 3, 4, 5, 6, 7, 8, 9. There's just one more than each of the things. Okay, let me add one more to each of the things. What about like perimeter? I haven't done perimeter. We'll come to that in a second. And just to check, if I do this, it's still fine. Yeah, so perimeter there is going to be different, but it's the same as doing that. But the perimeter of the entire area could be relevant. But let me also add one, because that will be the number of vertices, number of lines, sorry. So 4, 2, 3. Well, it's between the two. 4, 3, 6. I don't know. I'm not. Yeah, it's already looking bad. Perimeter. So which is the same as multiplying them both by 2 and then adding them together. So 6 plus 4, 10. 6 plus 4. Wait, what am I doing? 10 is the second one. The second one is 10. Which is this one that I'm on now. 1, 2, 3, 4, 5. Yeah. Why don't I add them times by 2? That's better. 4, 8. Okay. Add them 7, 14. Add them 4 times by 2, 8. Add them 6 times by 2, 12. Add them 6 times by 2, 12. But it's not the same answer at the end. It's 9 and 8. So the 3 by 3 and this 4 by 2 square both have the same perimeter. There's the area. I've already thought about the area a lot. There's the circumference. If these were the diameters of circles and the circles were made out of paper and then they were blasted at each other in a large hadron collider, how much energy would be emitted? 8 joules. Four and 3, 3. 8 and 4, 5. I have to stop. I have to stop. Or I have to get a hint. The comments can leave a hint, but I want to finish the game. I'm getting close, and this is a while away. I'm going to see if anybody else asked for a hint on the Thinky Puzzle Discord. That's what I'm resorting to right now, because I can't stand this. Is this even searchable? Can I search for like -9? Maybe I have to search for understand and then just look through some of the posts. Oh, I'm searching for. I need to search within the. Okay, there we go. -9. Lots of things with just 9 appearing in them, showing up. Skip past all that. It's probably going to be in the playing. Yeah, that's also filtered down to the playing. In playing. Okay. Menderberg says. Okay, hold on. Oh, I lost it. -9 in playing. I'll do. Menderberg says, beat the game, but I haven't actually figured out the rules for 8 and 9. Okay, I figured out the second one of those. Menderberg found out the second one before the first one. So the next thing says, the something threw me off, like it's spoiler tagged. I might look at what that is so that I'm not thrown off. The 32 to 5 mapping threw me off completely. Made me look into. And apparently the rule for the other one is too complicated. The rule for the other one's fine. We're saying this rule isn't complicated. 8, 4, and 5. Okay, the 32 to 5 mapping threw me off completely and made me look into binary factorization, divisor counting shenanigans. Yep, well, I've been through all that. Okay, well, at least that gets rid of those. 32 to 5 mapping. Like, maybe that's not. Maybe the 32 isn't relevant again. stay in the 4 somehow. Somehow. I think I've had a rule that works for the other one, but it seems borderline too complicated to be intended, but probably is. Smallest area that can be filled in with a full width rectangle and... Yeah, okay, that's... Yeah. Let's search again. I apologize for all this downtime. This has been the most boring video that's ever existed. Search. Did anybody else talk about it? I'm going to guess probably not. No, we've gone way too far back in time. Okay. Well, I could ask for a hint there, though. Apparently it's less complicated than the other. No, because Mendelberg's other idea for the rule was like hugely complicated. It's curious that they were thinking about shapes that fit in, which I guess is just the same as saying like a fraction of something. So what way is 5 interesting? It's 1 more than the height. There's 2 of those fit in there. Yeah, but I guess it's just thinking about multiples. 32 and 5 mapping is really weird. What can I do about that? Like, it sounds like the answer is not going to be something horrendously complicated. 32, 5. How many months of the year have 32 days? How many of them have 24? 5. 5. What? Four and 3. 3. Pythagoras. It's the length of the hypotenuse. Nope. Uh, 3 by 1. Okay, looking at the puzzles, I see a connection 3 and this. What's the connection? 3 and this. That's the width of the thing. 6 and this. It's the width twice. There are 2 rows. 3 and this. It's the height. It's the smaller. It's the no. It's the something. Why that? Not that. Not that. Not that. Why that? Why the smaller of the 2? Why 5? It's the... I might have to ask for a hint. I'm going to ask for a hint, I think. Alright, I've asked for a hint, but it could be a while till I get one. So, let's keep looking. Let's keep looking, because I feel like maybe I'm just going to stumble upon it. Like, is there anything visually distinctive? The problem is it seems to be a very random, like, I guess with, what was the next one actually? Very different. Okay. Let's ignore that then. Like this one, like common, what even was it? 3, 3, 3. It's the greatest, least common multiple of the width and height. And that, I don't know if there's any visual way to get that. I suppose it would be the rectangle that would fill. It's like if I rotated, if I put water, if this was a container and I filled it with water, and I filled it with that much water, and I rotated it, it wouldn't fill up to a line on the other side. If I put that much in, and I rotated it, it would fill up to that line. That's one way to visualize it. I put water in and I rotate it, and if it fills up to a line, then that's the answer. And it's the least amount of water required to do that. Okay, let's put water in these. I'm going to fill that up. I'm going to fill that up. I'm going to fill this exactly a third. If I fill it up a third and rotate it, then I'm less than that. Okay. Three. The number of the level is 3. 3 from 4 and 3. 3, 3, 3, 3. I have no idea. Why am I still trying? Like, is any one of these supposed to teach you something special? Like, this is the only weird one. If I remove 5 from this, what's left? I mean, that's interesting to think about, I guess. Like, it could be to do with the size of the remaining area. Okay, let's subtract that from that. Well, for the first one, you get 0. Okay, I need to make some space on my whiteboard. For the first one, you get 0, and then 0, and then you get 9, and then you get 0, and 0, and 0, and you get 18, and you get 9, and you get 27. 0, 9, 18. Oh, they're all multiples of 9. 0, 9, 18, 27. Well, isn't that weird? What's this one? I don't have it written down anymore. Let me write it down. 9 by... Well, yeah, obviously this is going to be multiple. This is going to be 27 again. 9 by 4. 27. No, 9 by 4. I'm inputting 9. The total is 36. The subtraction is 27. And then it's this. I mean, I could see if it is. So what's left from this? 6 by 6. 36. Also a multiple of 9. I'm onto something, but why? Okay, hold on. So what I've learned is that the remaining space is always a multiple of 9. So why isn't this okay? Why is only wait, what was it? Fuck that. Why is only that okay? So this is, how many is this? This is 18. This is 2 times 9. Can I find a connection? Like with how many? What was the last one? I didn't write it down. Oh, whoops. This is also level 9. I hate it, but 3 by... sorry, what am I doing? I need to get to the last one. Okay, so what are the numbers? We've got 8 by 6. 8 by 6 is... so how many am I filling in? I'm filling in 12. And the total is 8 by 6. It is 36 again. Wait, 8 by 6. No, 8 by 6 is... Oh, no, hold on, I'm getting this wrong. 8 by 6 is 48. Minus 12 is 36, which is also a multiple of 9. Okay. Multiples of 9. Somehow relevant. The empty space is always a multiple of 9. But there's a specific multiple of 9. It's the highest. No, I don't think so. What's the highest multiple of 9 I could make with the empty space here? Nothing. Highest multiple of 9 I can make with this empty space here? Nothing. 9. Oh, God. It really is, isn't it? It's just... This is the worst puzzle in the game. The highest multiple of 9 I can make with this is that. Yeah, it's just like, obviously, all of my answers are less than 9. Yeah, except where, yeah. I think I've got the answer. I really don't like it. Like the number 9 is arbitrary. Yes, you can say, oh, it's level 9, so therefore it's not. No, it's still arbitrary. It's like with that level 27. The number was 7. Magic number 7. And then it's nothing like the previous one. I mean, yeah, sure, they are often different, but... So it's... okay, it's nothing to do... Okay, that's kind of a clever trick that's not to do with the amount that I'm shading in, it's to do with the amount that I'm not shading in. That's where it does have some relevance to the previous one. It's like it's flipping it on its head. But then it's just multiples of 9. I hate it. I didn't need a hint. Okay, that's the one positive that's come out of this. I asked for a hint. I didn't get a hint, but I solved it anyway. That's the worst puzzle in the entire game. For sure. 2 7s next. Yeah, let's hope the rest of 0 could be nice to me. That's going to be a really long video with lots of silence and lots of nothing happening, just me staring at a whiteboard in my room and you can't see. So, yes, I'm done. Yep. We'll do the 0s next time, I guess. So that's the rest of the game. Yeah. Okay. Goodbye.